Hello and welcome back. And in this video we're going to be working on some elementary function graphs. Throughout the course you're going to be working with graphs of functions, and we're looking at some things that we're going to be um, making changes to are just the base models of graphs. So we're going to be doing these throughout the course. And what we're going to be doing today is working with the absolute value function, number 3 here, and number 4, the square root function. In the second video of this, we'll be working with the reciprocal function, number 5. So let's start with the absolute value function. Okay, the absolute value function is a function where the value is going to be the distance from 0 of the value. So if we, for example, put in a value of -3, the absolute value of that is going to be +3 because it's 3 values away from 0. All right, so a -3 is going to give us a +3. -2 is going to give us +2 because that's 2 units away from 0. -1 is going to give us +1 because it's 1 unit away from 0. 0 is going to give us 0 because it's 0 units away. 1 is also going to give us 1 unit away, and 2 will be 2 units, and 3 will be 3 units. So, and so forth. So the graph of this is going to look like, it's going to start here at 0, 0. Let's start at -3. -3, +3, it'll be here. And then there, at -2, +2, -1, +1, 0, 0, 1, 1, 2, 2, 3, 3, and so on and so forth. So the graph of this function is going to look like a V-shaped graph at 45 degrees on both sides of the y-axis. Has some symmetry in the middle, meaning we can fold right along this line, and we can take a look at it. So zoomed out here, so let's go back to 100%. The domain of this function is going to be all real numbers, so it's going to be -infinity to +infinity if we write it as an interval notation, because that means we can put any number out in to the function. Any value will have an answer. The range is what values come out. If we look at this column right here, we can see that we're going to look at numbers greater than or equal to 0. So their range is going to start at 0. We use a closed bracket there to include 0, and it goes to infinity or upwards to a large value. Now if we're looking at this question, where is it increasing? We would say that it's increasing as we get bigger than 0 here. We're going up on the graph as we go to the right. As we travel along this graph, starting at the leftmost point, it drops down to this point, and then it goes back up, goes up. So this is the increasing part on the graph. So we'd say there it would increase from 0, which we don't include it because it doesn't look like it's increasing or decreasing at 0. And it's going to go up as it goes to the right. So it's 0 to infinity, and it's decreasing on -infinity to 0. It drops down at this point from here. As it travels left this way, it drops to this point, this being the minimum point of the absolute value function. So that's the absolute value function and some of the values there. The next function we're going to look at is the square root function. So in the square root function, we're going to have some, we're going to plug in some values as well. In this function, if we try to put a negative number in here, we won't be able to get a value. The we can't take the square root of a negative value and get a real number, so we can't graph. On this graph, it's a real number graph, so we would have to plug in our first value would happen to be 0 is our first value that we could plug into this curve, because we can take the square root of 0 and get 0. We can then take the square root of 1. If we take the square root of 1, we get 1. If we take the square root of 2, if we take the square root of 2, we put 2 in there, the answer would be the square root of 2. And that's not an exact, it's an irrational number. It's approximately 1.4 if we look that value up on our calculator. We look at our calculator over here, and we take the square root of 2, and we get about 1.4 on the calculator. Square root of 3 is another value. That's about 1.7 on the calculator. 4, if we put 4 in there, we get the square root of 4. That's 2. And then so forth. So if we look at this values, we have 1, we have 0 right here, 0, 0. We have 1, 1. At 2, we're going to get 1.4. At 3, we'd have 1.7. At 4, we'd be at 2, and we'd be going up in that way. If we want to look at the graph of this, let's take a look at the graph of this on the calculator. Square root of x. I'm going to set my window so it looks similar to this. It looks like we go out to 2, 4, 6 on each one, so -6 to +6 in both directions. So my window will look the same as my window in the problem. And I push graph. So our graph should look similar to that, and it does. If we look at this graph, it's going to look similar to the graph on the calculator. We're going to go this way. It travels off to the right and increases. So it's similar to the graph on the calculator. Now the domain of this is what values we can put in for x, the x values. In this case, as I said, we can start off with 0 as our x value, and we can't put negatives in, so we have to go upward to the highest value we can think of. And in this case, we put 0 to infinity. The range here, the range is the values that come out of this thing, and it looks like our range values start at 0 also and go up. So our range values are going to be the same as the domain values. Those answers that come out are also going to go from 0 up. Now on this one here, we're increasing throughout the thing, so it's going to be increasing on the same interval, 0 to infinity, and it's never decreasing because it never goes down. It only goes up as it goes to the right. Our values, as we increase here, only increase here. They don't start dropping down on us, and then we can see the function travels to the right. It goes up. So increasing to the right, increasing to go up. So right is your domain, up is your range. All right, we're going to continue with the next function on the next video. We're going to look at the reciprocal function. So that's what we have on our next video.